Hey guys, welcome back to Pure Science Education, and here is another video linked to fractional distillation and the fractions, which is called cracking. Now, cracking is linked to the hydrocarbon. Mainly we're looking at the alkenes here, and what it is, it's a reaction where the larger saturated hydrocarbon molecules are broken into smaller useful fractions. So let's get that down for you. Cracking, a reaction in which larger saturated, now remember the word saturated means the single bond alkanes. They are all four bonds are bonded to carbon. Hydrocarbons molecules are broken down into smaller useful molecules, and when we break these large hydrocarbons, which are saturated, which are basically the alkanes, they will break down into different things. So they'll break down into alkanes and alkenes. So let's have a look at them. So we're going to start off with originally the saturated hydrocarbons, which is basically the alkanes. And just to remember, alkenes have single bonds, and there are carbon has 4 bonds, so each one is full, so hence it's saturated. The generic formula for alkanes, just if you can't remember it, and you're figuring out the number of carbons in the alkanes, is CnH2 times N plus 2. If you was to draw any of them in the exam, that's the formula you need to remember. So what we're going to make, so that was originally what we started off with, and then the product of cracking. The products of cracking, like I said, will include some alkanes and alkenes. Now, do you remember alkenes? They were the double bond hydrocarbons, which means they belong to different homologous series. And their generic formula, if you don't know, generic formula really easy if you have to draw display formulas in the exam. The CnH2 times N, and this time you will see that the difference of plus 2 has been taken away, simply because it's a double bond, not a single bond. Now let me show you in terms of exams. These are definitions they can ask you. In terms of exam, they can ask you to crack a hydrocarbon. So let's just take hexane as an example, and we're going to crack it into butane and ethene. Now, it doesn't matter what fractions you crack them into as long as they're balanced. So I'm going to go C6H14. That'll give me, I'm going to do C2H4. Now, another thing they can do in the exam is they can leave the formula blank, and you need to figure out what the missing gap is, and all you need to do is then do C6 take away C2, that gives me a C4, and H14 take away 4 gives me a H10. That's a typical exam question where they leave a blank for you to fill in. Now they can give you any formulas to break and crack. As long as you have an alkene and an alkene, then that's fine. Now, just very quickly, while I'm looking at cracking, there are two types of cracking. One is a catalytic cracking, and the other one is steam cracking. Again, a 6-mark exam question for the GCSE students out there. So let's do a quick comparison. This uses approximately 550 degrees centigrade temperature. As the name suggests, it has a catalyst, and the name of the catalyst is xylite, which is basically aluminium oxide and silicon oxide. So that is aluminium oxide plus silicon oxide is a mixture of the two, just in case you get to ask what it's made out of. And on the other side, if I was to look at themes, as its name suggests, it's going to be over 800 degrees centigrade, and no catalyst is needed due to the high temperatures. I hope this helps you in terms of your exams. Quick whiz through cracking. All the best. Thank you.